Hello everyone, I'm Zeze and I'm one of the students of Mount Insan Cendekia Kota Batam, and today I will show you how to do some question for Chemist AS level of Cambridge, and hope you guys understand, and I hope we got straight A's in our exam.
So let's jump to the first question. First question is number 4. In which option do all three particles have the same electronic configuration and the same number of neutrons? So I already write in here. I will show you the question in here so you can see it clearly. So same number of neutrons. How do we calculate the neutrons? The neutrons is equal to mass molecular minus electron. So let's take a look in this. -3 is the charge, while the 15 is the mass molecular. The 7 is the electron. So the neutron of the nitrogen is 15 minus 7 equals to 8. This question asks us to look at the three particles that have the same neutrons. The neutrons of the oxygen is 8, while the neutron of the fluorine is 10, so it's not the same, it's wrong. How about B? The neutron of the oxygen in this is 18 minus 8, so it equals to 10, while fluorine in this the neutron is 10, and for the neon is also 10, so it's same. B is the answer. Let's see the next question. The next question is, which molecule has an equal number of bonding electron and lone pair electron? So, equal number of bonding electron and lone pair electron, we look at the option A. It's a boron 3 hydride. We draw the electron valence of boron in here. Electron valence of boron is 3, so 1, 2, 3, while H is just 1, 1, 1, 1. So it's bonding in here, but there is no lone pair in the center of atom. There is no lone pair, so it's wrong. How about option B? Option B is carbon dioxide. The electron valence of the carbon is 4, 1, 2, 3, 4, while oxygen have 6, 1, 2, 3, 4, 5, 6. So it's bonding in here. How many number of bonding electron? The bonding electron is 1, 2, 3, 4, 5, 6, 7, 8, while the lone pair is 1, 2, 3, 4, 5, 6, 7, 8. So it's same. The answer is B. So let's jump to the next question. The next question is, there's a question here, and the question is, which volume of hydrogen will be produced? So I already write in here. So the gram of the methane is 0.8, and the gram of the steam reactant is 1.35 of gram. So which volume of hydrogen in room temperature condition? So we have to calculate the mole first. The mole is equals to G per mR. So the G is 0.8 per. So this is the next question. The next question is asking us for calculate the hydrogen of the equation here. So first, if we want to calculate the volume of hydrogen which is in here, we have to know the mole first. The formula of mole is N equals to K per mR. So the gram is equal to 0.8, and for the mass molecular is 16 because carbon is 12 and the H is 4. So 12 plus 4 is equal to 16. Equals to 0.05. This is just 1 mole, while hydrogen in here have 4 coefficient in here, so you multiply by 4. This equals to 0.2, and then we calculate using this formula. Moles equals to volume per 24, so the volume is equal to 4.8 decimeter cubic. The answer is C. So let's jump to another question. This question is, what is the mass of the sample of methane, which is CH4? So I already complete the data in here. There's pressure, volume, and temperature. What is the mass of sample of methane? So we use this formula PV and RT. So we have to input the data in here to this formula, and we got the mole. The mole equals to 0.2. And then if we want to calculate the mass, we have to put it in the formula of mole. N equals to gr per mr. The mr is 16, same like the question before. So the mass of the methane, which is CH4, is 3.29. The answer is D. The next question is, what is the concentration of oxygen gas in the water? So again and again, I already complete the data. There is the volume of the water, the volume of the oxygen, the pressure, and the temperature. So what is the concentration of oxygen in water? So we use this formula PV and RT, and then put the data in here, and then we got the mole, which is 2.37 times 10 to the power of minus 4. So the concentration we get from mole per volume, so it equals to 1.17 times 10 to the power of minus 3. So the answer is B. In which pair do the molecules have the same shape as each other? So the option A is H2O and carbon dioxide. How do we know this have the same shape or no? So we have to draw the cross and dot diagram. So we find the electron valence first, and then we have to draw it. So H2O, the shape is bent, while the carbon dioxide is linear, so it's not the same. So the option A is wrong. While B, the H2O we already got in here, it's bent, while sulfur SC2 have the shape is bent also. So this is half bonding 2 and 2 lone pair. So it's like this. So it's bent. It's the same shape. So the answer is B. So there is ammonia reacted with acid to form ammonium ion in here. So the question is, which row is correct? This question asks about the shape and the bond angle in ammonium. So I already draw cross and dot diagram in here. Again and again, you have to find the electron valence first of the nitrogen and the hydrogen. So in here, but I think because the charge in here, the one electron free electron in here is gone because the plus in here. So this shape become tetrahedral, which is like this, and the bond angle is 109.5. So the answer is D. Next question. Which diagram represents the overlap of two orbitals which will form a pi bond? The A option is will form a sigma bond, not a pi bond, because this is the subshell S and this is the subshell S, which will form the sigma bond, while the option B is form the pi bond. So the answer is B. It's just a memory, guys. No need to calculate, and you guys have to know this. The next question is, what is the enthalpy change of neutralization of hydrochloric acid? So we already know the data in here. I already collect the data. So if we want to calculate the enthalpy change of neutralization, we have to calculate the color first. The color equals to mass times the coefficient and the change of the temperature. For the mass, we have to add this volume and then times this, and then we got the result 3.1235 kilojoule, and then we have to calculate the mole of the hydrochloric acid, and then we got 0.1, and then we have to put that data in this formula. Delta enthalpy change equals to color per mole, and then we got the result is 31.4 kilojoule mole to the power of -1. So the answer is B. The next question is, in this question there's a data about delta high combustion carbon and then combustion of hydrogen, and then also given enthalpy change of formation of ethane. So all you have to do is make the equation first. So enthalpy change of combustion of ethane. Ethane is C2H6. So we have to react that with oxygen, and then it will having product water and carbon dioxide. All you have to do is make the equation and then balance it, and then just put the data. Because this is have the equation 2 in here, so you have to multiply the combustion of hydrogen with 2, and then for the enthalpy combustion of ethane is reactant minus product, not product minus reactant. This is you have to remember this. Enthalpy change of combustion always reactant minus product. So the answer is B. So next question, using the average Bond enthalpies in the table, this is the table in the enthalpy, what is the enthalpy change of combustion of ethane? This is the equation. We have to make sure the equation is already stable or not, and then we calculate. So all you have to do is look at the bond in here and look at the enthalpy change, and then you have to calculate it. So I already put like this, so all you have to do is just like this, and then you have to do is calculate the enthalpy change of combustion. Remember, the enthalpy change of combustion is always reactant minus product, and the answer is A. The next question is, which reaction profile fit this data? So the data is X2Y, the delta, then the enthalpy change is positive, and for the Y to Z, the enthalpy change is negative. So for the enthalpy change, if the enthalpy change is positive, the product always bigger than the reactant. But opposite that, if the enthalpy change is negative, the delta product is smaller than the reactant. So which one is the answer? The answer is B, because the product X to Y, the product is more bigger, and for the Y to Z, the product is smaller. So the answer is A. The next question is, by using this information, what is the most likely failure for the enthalpy change of the following neutralization? Because the ratio of these two equations is balanced, so the enthalpy change is 114. So the answer is minus 114. So the answer is C. Just that simple, guys. The next question is a little bit quite complex, so we have to pay attention to this question, okay? So there's equation 1, and then there's 3 more equation in below in here, and there's the enthalpy change of that. The question is, what is the enthalpy change of the process shown in equation 1, which is in here? I already make the way, so all you have to do is um, all you have to do is write the whole equation in here, and then look at the main equation. There is n hat 3. In this 3 equation, where is the n hat 3? In here, right? But this is 4, this is 1. How do we change it? We divide it by 4. If we divided the equation with 4, we have to divide the enthalpy change with 4 also. So it becomes like this. And then after that, we also do the same, and then we find another equation. So this is in here, there's NHNO3. Where is the NHNO3? In the third equation. So we have to divide this with 4 also to make it 1. 4. And then it's step 1, guys. Step 2. Sorry. And then we calculate like this. We already divided it by 4, and then we got this. We got the result in here. I already do it like the usual, and then there's one equation more. This is the second equation, and do the same thing like the equation 1 and 3. All you have to do is, there is NO in here, but this is 1, this is 2. All you have to do is divide it by 2 to make it 1. And also, again and again, the enthalpy change have to divide it by 2 if the coefficient is divided by 2. And then we got the result. The enthalpy change is all the enthalpy change that already divided by 4 or by 2, and then the answer is minus 370. The answer is B. So the next question is, in which reaction is water behaving as a Bronsted-Lowry base? A Bronsted-Lowry base, FYI guys, I'm so sorry I didn't write the explanation, I just talked and pointed in this paper. So a Bronsted-Lowry base is a substance that accepts a proton. If the substance is gain H+, it becomes acid. If it's lose H+, it became base. It will be base. There is an equation in here, so all you have to do is look at the equation. Is it gain H+ or lose H+? And then we'll look at this. This is H2O. This is H3O. It means it accepts H+, right? And this is H3PO4, H2PO4. This is the H. This H is lost the hydrogen. So the answer is B. The next question is, in which reaction is the underlying substance acting as a base? I already told you. A base means lose H+ or accept H+. And then for the gain H+ or donor H+ is the acid. So there is HNO3 in here and H2NO3 in this side. It means the H in here is gain another H, so it became H2. It means the H in here is acting as a base, and then this is acid. So the option A is wrong. How about B? This is H, and there's no H in here, so it's lost H. So it's a base, and this is the acid, so it's wrong. how about this? In here, this h and this h different, right? This h is lost. Yes. What about option C? H-O-3. The oh, where is the h? This h is loose, helpless. So if the element in here was helpless, it became base. So it is acid base. So the answer is C. The next question is, which statement explains this result? 1. Acid 2 has a lower pH than acid 1. Acid 2 have a lower pH than acid 1. Right, because it's more soluble. Wrong. So this statement is right and this reason is wrong because the solubility didn't affect anything at the pH. Number 2, base 2 has a higher concentration of hydroxide ions on the solution than base 1. Right, base 2 has a higher concentration ions in solution than base 1 because it contains more hydroxide ions. Acid 2 dissociates less than acid 2. Acid 1 dissociates less than acid 2. Acid 1 dissociates less than acid 2 because acid 2 is more stronger than acid 1. So the factor that affects the pH is the strong or the concentration of hydroxide. So the answer is C because 1 is wrong, right? Nope. So the answer is C. So the next question is define enthalpy change of formation. Why I'm wrong in here? This is because I write when one of element. This word element is wrong. By standard element to complex in standard state. So the right one is 1 mole of a substance is formed in standard state. Remember that, okay? There's a table and this is the enthalpy change of formation in H3 and hydrochloride. We have to calculate the enthalpy change of reaction of Cl2 and NH3. So I already make the reaction in here. Change of Cl2 and NH3. So we have to reaction them first and then we balance it and then we calculate the enthalpy change for NH3 because the coefficient is 2 we have to multiply by 2 so 2 times 46 minus 46 and then for the HCl we have to multiply by 6 because the coefficient is 6 and then we got the change is minus 460 kilojoule mole minus 1. Thank you guys. Let's move to another question. This question want to us to complete this table by do this equation. Standard enthalpy change for formation for Fa2O3 and standard enthalpy change of formation for carbon monoxide. So I already write the equation. So this is for the Fa2O3 and this is for the carbon monoxide. Remember, the formation always the standard element to the complex element. And then for the second one, use the data in table 4.1 to calculate the enthalpy change of reaction delta HR in kJ mole minus 1 for reaction 2. So the main reaction is in here, this one. So for Fa2O3 in here, but it's the opposite side, we have to move to the another side so it's become a plus. And for this, because the coefficient is 3, we have to multiply by 3, and then for this also like that. And then we got the delta. The enthalpy change is reactant minus product because this is the formation. So it's become minus 24.8 kilojoule mole minus 1. So move on from paper 1, we straight to the paper 2. In paper 2, there's question that told us to state the number of occupied orbitals in an isolated atom of 36 krypton. So all you have to do is write the electron configuration. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and 4p6. Because the krypton is 36, right? So, which one the sharp shell S? This, and this, right? There's in here. How about P? You do the same way as D. So, the subshell S have 2 blocks in here that can be filled by electron, while P is 3 and D is 5. So, type of orbital S, number of orbital. There, each of subshell S, there's 2 blocks, while P have 3 blocks and D have 5 blocks. So in here, the number of orbital is 1, 2, 3, 4. 4 blocks, and for P is 1, 2, 3. Every single of these 3 have 3 blocks, so it means 9. And for the D, it's just 1, so it's 5.